This video is for educational and entertainment purposes only. This video does not contain information on how to perform these reactions safely. Do not attempt to recreate anything seen here at home. In this video, I react a solution of calcium propionate with a solution of sodium carbonate to produce sodium propionate and insoluble calcium carbonate. Reactions such as this are known as a double displacement or metathesis reaction. I am performing this reaction on a 1 molar scale. So first I weigh out 1 mole of calcium propionate. This is easily obtained online as it's used as a preservative in baking. I have not been able to find sodium propionate online, or for that matter, simply propionic acid, so this seems to be the simplest way to produce propionic acid in a home lab. Next I add 1 mole of sodium carbonate to a separate flask. Then a stir bar is added to each flask and an appropriate amount of water is added to dissolve everything. I usually use about a 5% excess to the theoretical amount of water because I've found that the theoretical calculated amount of water to dissolve things is never sufficient. Next, heating and stirring are turned on and I wait for everything to dissolve. Sodium propionate is useful mainly as a precursor to propionic acid. Propionic acid can be used for a number of things, but I plan mostly to use it in esterification reactions. While calcium propionate can be reacted directly with sulfuric acid to make propionic acid, it's an undesirable reaction because of the calcium sulfate produced being insoluble in pretty much everything and gumming up the reaction. Distillation and filtration are not particularly effective at separating it. This reaction produces calcium carbonate, which is much easier to separate. It settles out much faster than calcium sulfate, and is much easier to clean up simply by using a bit of hydrochloric acid. While adding an additional reaction step to producing propionic acid does cause some loss of yield, I still think this is better than using calcium propionate directly. In this step, I add the calcium propionate to the sodium carbonate solution. I do so quickly under strong stirring, and you can see an immediate white precipitate of calcium carbonate. This is our double displacement reaction. When an ionic compound or salt is dissolved, it dissociates into positive and negatively charged ions. Take sodium carbonate for example. It breaks into positively charged sodium and negatively charged carbonate ions. These ions are then free to interact with ions of a complementary charge. In this case, the negatively charged carbonate from sodium carbonate can interact with the positively charged calcium from calcium propionate. This forms calcium carbonate, which is extremely insoluble in water and drops out of solution immediately. This drives the reaction to completion. Next, I wait for the solution to settle, and I filter off the calcium carbonate from the relatively clear solution. The slight yellowing is due to impurities from my sodium carbonate, which was a lot dirtier than I thought. In the future, I'll probably just use this for neutralizing any acid spills, and I'll invest in some relatively clean new sodium carbonate. With the calcium and carbonate ions no longer in solution, all that remains are sodium and propionate ions, giving us our desired product, sodium propionate. Next, I need to boil off the excess water to drive the sodium propionate out of solution. In this case I use simple distillation, but it's really not necessary. You can just, boil it off in a flask. Next I vacuum filter off the crystals that have formed and collect the remaining liquid. I have to reboil this and refilter it several times to collect all of our desired product, as sodium propionate has a solubility of about 1 gram per milliliter, which means it's extremely soluble. It's also possible to dilute the solution with another solvent in which sodium propionate is not soluble. In this case you could use acetone, but I think that's fairly wasteful. It's easier just to boil it down. Once we've recovered all of our product in crystal form, it still contains quite a bit of water. In fact, I think this is a hydrate salt. I couldn't find a lot of information about what sort of hydrates sodium propionate forms, but it needs to be heated and the water needs to be driven off. So I add everything to a drying dish under gentle heat and drive off the water. Because this is a hydrate salt, it will first melt before the water boils off, and we're left with a dry, white, opaque powder. The product is then weighed and stored for future use. My yield was slightly over the theoretical 192 grams. I think this is due to impurities in my sodium carbonate and the small amount of residual water that may remain.